Welcome to video number 8. Today we're going to derive the voltage divider equation. A basic voltage divider just consists of two resistors in series, and the output of the divider is taken across the second resistor as shown in the schematic diagram here. Now what we're going to do is derive an equation that gives us V out in terms of V in and R1 and R2 without explicitly requiring us to calculate the current. To do that, however, I'm going to start by writing the equation for I1, which is simply given by Ohm's law. I1 equals V in divided by the total resistance, V in divided by R1 plus R2. Now the output voltage is equal to I1 times R2. V out equals I1 times R2. And now if we take the fraction and substitute that in for I1 in the second equation, we get V out equals V in times R2 divided by R1 plus R2. Now that's a perfectly acceptable equation, but traditionally what we would do is bring V in out of the fraction, and we get V out equals V in times R2 over R1 plus R2. That's the traditional way we would write the voltage divider equation. And the reason we do that is to kind of separate out the fraction from V in. And the point of that is that the fraction represents the gain of the voltage divider. Now, gain, by definition, and we'll represent gain in terms of voltage by A sub V. Voltage gain, again, by definition, is V out over V in. In this case, if we divide both sides of this equation by V in, we get voltage gain equals R2 divided by R1 plus R2. So that's why we can think of this fraction as being the gain of the network. It tells us how V out relates to V in, and it's related by this fraction. And notice that this is always going to be less than or equal to 1. Okay, so V out will vary between 0 volts and V in, whatever that is, depending on the values of R1 and R2. Now, here's all of that stuff condensed into a nicer form that you could take a screenshot of or whatever, just to follow through very methodically. All right. Now, here's an example of an adjustable voltage regulator. It's a device you're probably all familiar with, a potentiometer. All right, we have the two end terminals and this middle terminal, which is called the wiper. The wiper moves up and down, determining the relative values of the resistor up here and the resistance down here. Here we have it hooked up as an adjustable voltage divider with a 10-volt source driving it. The output can be varied between 0 and 10 volts. All right, I'm going to show you a couple potentiometers here. This is your typical potentiometer. This is a 10K ohm audio taper pot. We'll talk about tapers some other time, but that's a typical potentiometer. Here's a potentiometer with an on-off switch built into it. Here is a slide potentiometer, a dual gang stereo potentiometer, and this one happens to have an extra tap for some loudness control in audio equipment. Again, something we may discuss some other day. Here is a 100-turn potentiometer with a numerical readout. Kind of interesting, old school. And here we have a couple of trim pots. This is a 10-turn 500 ohm potentiometer, and here's a 1-turn trim pot. So an assortment of potentiometers. And finally, before we end this video, I wanted to kind of relate back to something I mentioned previously in the Thevenin's theorem video, and that was the concept of ports. Now, the voltage divider could be considered to be a 2-port network. We might have a divider inside this black box. It's got 2 input terminals, 2 output terminals, so the input and the output are considered ports. And relating back to what I was talking about in terms of voltage gain, generally we can represent something that has voltage gain as a triangle with just 1 input line and 1 output. And the output is equal to the voltage gain of the amp times V in. This could also have a voltage divider in it. It's just that if that were the case, the voltage gain would be between 0 and 1. But in general, the gain of an amplifier could be any real number, say 2, 10, -50, 0.3, whatever. But it could also be a complex number as well. And we'll see examples of all of this stuff in upcoming videos. But for right now, I just wanted to introduce this general concept and kind of relate it back to the voltage divider, which can be thought of as having a voltage gain. All right, that's enough for today. I will see you next time.